Okay, so all this time we've been saying that fractions are perfectly good numbers. But now we're bending over backwards to avoid having to graph them. That seems wrong somehow. And in fact, we can graph fractions perfectly well, as long as we set up our axes carefully. In particular, if we know which fractions we want to graph, we can set up our axes so that we show those fractions. For example, let's say we want to graph the equation 2x plus 3y equals 1. The x-intercept, where y equals 0, is 2x plus 3 times 0 equals 1. 2x equals 1. Multiply both sides by a half, and we get x is a half. The x-intercept is at 1/2, 0. The y-intercept, which is where x equals 0, well, we've got 2 times 0 plus 3y equals 1. 2 times 0 is just 0, so this is really just 3y equals 1. Multiply both sides by a third, and we're left with y is 1/3. So x is 0, y is a third. Okay. We don't want to take any extreme measures in order to not have to graph these. We want to just graph these intercepts. How could we? If we want to draw our axes on the same scale, we need a common denominator. So 1/2 and 1/3. It's easy to see that their least common multiple is 6. If you don't immediately see that, you can use the calculator. 3 times 2, therefore 1 times 2. 1/3 is 2/6. 2 times 3, therefore 1 times 3. 1/2 is 2/6. 1/2 is 3/6. So our points are 3/6, 0, and 0, 2/6. I'm going to draw my axes going out to 1 in each direction, but I'm going to have a grid line every sixth. But I'm going to have a grid line every sixth. That is, I'm going to draw this so that 1 takes up 6 boxes. So here are my axes. I haven't actually labeled all of the sixths, but I can count them out, right? 1, 2, 3, 4, 5, 6 to make up one whole unit. Where will my points be? Well, I have an x-intercept at y equals 0, x equals 1, 2, 3/6. I have a y-intercept at x equals 0, y equals 2/6. And now I'm ready to draw my line. There we go. Now, that's option 1. We can also just draw our axes on different scales. Suppose that we want to graph 5x minus 3y equals 2. Right, then my x-intercept where y equals 0, is 5 times 0 is 5x minus 3 times 0 equals 2. 5x equals 2. Multiply both sides by a fifth, and we get x is 2/5. My y-intercept, where x equals 0, is 5 times 0 minus 3y equals 2. Negative 3y equals 2. Multiply both sides by negative a third. We get y is negative 3/2. My x-intercept then is going to be 2/5, 0. My y-intercept is going to be 0, negative 3/2. So my second option is to just draw an x-axis that shows fifths and a y-axis that shows halves. I want my x-axis to show 2/5 and my y-axis to show negative 3/2. I'm just going to draw my x-axis so that it takes 5 boxes to make up a unit, and my y-axis so that it takes 2 boxes to make a unit. And I just want to make sure that I have at least 2 tick marks on my horizontal axis, at least 3 tick marks on my vertical. So now I can plot x is 2/5, y is 0, y is negative 3/2, x is 0. And there's my graph. Beware, however, we talked about those steep, shallow things with slope. If your axes are on different slopes, you can't tell whether the graph is steep. If your axes are on different scales, you can't tell just by looking whether your graph is steep or shallow, because this distance here is actually much, much smaller than this distance here. Right? 2/5 is much, much less than 2/2. So our graph is kind of stretched out, and we can't really see what's going on with its shape. However, sometimes we really, really need our axes to be on different scales. For example, suppose we want to graph y equals negative 100x plus 700. We certainly don't want to graph that by having our x-axis go all the way up to 700. We don't have 700 squares available to us. And we don't want to graph something where we can draw a slope that really looks like negative 100. Instead, we'll just draw a y-axis with tick marks every 100, and an x-axis with tick marks every 1 as usual. And I've spread them out a little bit just to make our graph a little more spacious. Now we can plot the y-intercept. And we can use the slope. But remember, when we go over 1, that's this far. And when we go down 100, that's this far. So our graph is going to look something like this. Why on earth would we have numbers on wildly different scales like this? Well, that actually happens all the time when we're talking about real-life situations.